Suppose alpha increases on closed interval AB, A is less than equal to x0 is less than equal to B, alpha is continuous at x0, f of x0 equals to 1 and f of x equals to 0 if x does not equal to 0. Prove that f belongs to R alpha and that integral a to b f of d alpha is 0. Let P is a partition, a equals to x0, x1, x2, so on, xn equal to b, be a partition for closed interval AB, and let x0 belongs to delta xi. Since alpha is a continuous at x0, therefore for epsilon greater than 0 there exists delta greater than 0 such that modulus of alpha x minus alpha x0 is less than epsilon for modulus x minus x0 is less than delta. Again, since alpha is an increasing function, we have alpha x minus alpha x0 is less than epsilon for 0 is less than x minus x0 is less than delta, and alpha x0 minus alpha x is less than epsilon for 0 is less than x minus x0 minus x less than delta. Let P is a partition with mu P is less than delta, therefore delta xi equals to modulus of alpha xi minus alpha x0 plus alpha x0 minus alpha xi minus 1, which is less than equal to of modulus of alpha xi minus alpha x0 plus modulus of alpha x0 minus alpha xi minus 1 less than epsilon plus epsilon equal to 2 epsilon. Supremum of partition P function f and alpha equals to sigma I varying from 1 to n f of t I delta alpha I equals to f of t I delta alpha I equals to 0 when t I does not equal to 0, and delta alpha I equals to delta alpha I when ti equals to x0. Therefore modulus of supremum of partition P f function f alpha equals to when ti does not equal to 0, and modulus of supremum of P f alpha is less than 2 epsilon when ti is equal to 0. In both the cases, limit mu p tends to 0 as supremum of P partition P function f alpha equals to 0, which implies f belongs to R along closed interval AB, and integral a to b a function f d alpha is 0.